Hello everyone. Title of this video is section 7.3 on simplifying complex rational expressions or complex fractions. In this video I'm going to be working on a version of your Knewton Alta assignment for section 7.3. Please understand that the version I'm working on, the questions I will be seeing in this video, are not necessarily going to be the exact same questions you'll see when you work on the assignment on your own. Alright, but the objectives will be the same, the types of questions will be the same, how you would work on them would be the same. So I'm hoping that watching me do this here will help you when working on the assignment yourself. Alright, and I'll ask you to do this too. Whenever a new question pops up, pause the video and try to work on that question on your own first, and then watch me do it. Because if you're just watching me work on this stuff and not practicing on your own, what are you learning? You're probably not learning much of anything. Okay, so here's the assignment page. You will not see the words preview of, you'll just see the title of the section, title of the assignment, the mastery bar telling you how far along you've gotten in the assignment, the objectives, and this section has two objectives that goes over two different methods of simplifying complex rational expressions. So notice both objectives start with the words simplify complex rational expressions. And they're going over two methods. One's by using the least common denominator, and the other method is by writing the expression as division. And I'll be doing both. Alright, I'll be doing both methods, but please know that both methods give you the same results. So if after watching these and practicing, if you like one method over the other, you can use that one method every time to simplify a complex fraction. Both methods are equally valid. Alright, then you have your questions. And every question should have a feedback button at the bottom where you can send feedback to Knewton if you wish. You will not be seeing the instructor cheat button. It's for instructors only. But you will have the more instruction button, which I would recommend using when you're struggling. This is good. You click on this, you'll be provided with reading material or videos that'll hopefully help you with whatever objective you're working on. Alright, so in this first question, the objective is simplify complex rational expressions by using the least common denominator, or by using the LCD. Alright, so I'm assuming here that you know how to find the least common denominator of several fractions. So I'm just going to be writing what the least common denominator is, and then using it to help simplify the complex fraction we're given. Now a complex fraction, it's a fraction in which the numerator and denominator may also have fractions. So you have fractions within fractions. So you see usually the main division bar, the main fraction bar, is the longest one in the middle here. See where my cursor is on the screen? That middle bar. And then you see above that, that's the numerator. You see how the numerator also has two fractions being subtracted? And you see how everything below the main bar, which I'll call the denominator, see how the denominator also has a fraction in it, 6 over x minus 1. So you have fractions within fractions. That's what makes a complex fraction. Alright, so I'll write this out and we'll simplify it using the LCD method. Okay. So, as I was saying, a complex fraction is has fractions within fractions. Say I'll point this out, right? Usually the longest division bar or the longest fraction bar is the the main division in the fraction, and everything above that longest bar or that main division bar is the numerator of the complex fraction. So this 2 over x minus 1 minus 7 over x minus 4, that's the numerator. And then everything below this main division bar will be the denominator of the complex fraction. So this 6 over x minus 1 is the denominator. And then, within the numerator and denominator, there are other fractions, right? Again, fractions within fractions. And I'll call the denominators of these fractions the 2 over x minus 1, the 7 over x minus 4, and the 6 over x minus 1. I'll call the denominators of those fractions the lesser. I'll put quotes around lesser because they're not really lesser, they're not less important, but they're, they're the denominators of the fractions within the fraction, right? They're not the main denominator, right? The main denominator is this fraction, 6 over x minus 1, but it also has a denominator, right? It's denominators within denominators and denominators within numerators. So I'm just calling them lesser because they're not the main one. Right, so you have these lesser denominators. Now, again, the lesser denominators here would be x minus 1 and x minus 4 and x minus 1 again. All right, but no need to write that out. Right. I guess I will. There. Those three lesser denominators. So what we're going to do first with this particular method, where we're asked to simplify this by using the least common denominator, I'm first going to find the LCD of these three denominators. So real quickly here, right, the first denominator, x minus 1, that factors to just x minus 1. Simple enough, right? All these are factored completely. X minus 4 factors to x minus 4. Notice, remember, if you recall from a previous video, a nice method for finding the LCD was to list the factors of each denominator and line up any like factors in columns, and then the factors that showed up in these columns made the factors of the LCD, right? So x minus 4 is not x minus 1, so I leave a little space and put that over here in its own column. And then x minus 1 is the last denominator. Obviously, the only factor of that is x minus 1, and it's like the x minus 1 here, so I line it up in that like column. And then now that I've got all the factors listed and all the like factors in their own columns, the LCD is very simple to state. It'd be, x, that's the x minus 1 column, right? So x minus 1 is going to be a factor of the LCD times, and then got an x minus 4 column here. And there we go, right? There's the LCD. Right, so once again, I'm not going to do this for every single problem. I'll just kind of state the LCD in the future. Alright, so first you find the LCD, then you're going to multiply the numerator of the complex fraction and the denominator of the complex fraction by this LCD. Because remember, if you multiply a fraction, if you multiply the numerator of a fraction by an expression, you must also multiply the denominator by that same expression. That way, you get an equivalent fraction. So multiply the numerator and denominator by the LCD that we just found. Alright, so I'm going to rewrite out that complex fraction. So this is the way it looked, right? You have 2 over x minus 1 minus 7 over x minus 4 in the numerator divided by, and then 6 over x minus 1 in the denominator. Right, and I'm multiplying the entire numerator by the LCD, by this x minus 1 times x minus 4. And same thing with the denominator, right? Multiplying the whole denominator here by x minus 1 times x minus 4. Right? Multiplying the numerator and denominator of the complex fraction by the LCD. Now the whole reason for doing this is to get rid of those lesser denominators, right? Watch what happens. So the numerator has two terms. It's the difference of two fractions. So I'm going to be multiplying, right, each of those terms, right? We're multiplying the entire numerator by the LCD. So the numerator looks like this now. You have 2 over x minus 1 times x minus 1 times x minus 4. Then minus, and then the second fraction here, 7 over x minus 4 times the LCD as well, right? And multiplying. Basically, I'm just going through the numerator and denominator and multiplying every term by the LCD. Times x minus 1 times x minus 4. So that's the numerator multiplied by the LCD. And the denominator is just the one fraction, just 6 over x minus 1 times the LCD times x minus 1 times x minus 4. And the whole reason we do this, the whole reason we're multiplying the numerator and denominator by the LCD is so all those lesser denominators go away. They'll clear away, they'll cancel. Watch this, right? So up in the numerator, right, the first product here, see x minus 1 in the denominator of that fraction? There's a factor of x minus 1 in the LCD. Those cancel. All right, and I'm left with the following. For that first term, I have 2 times the quantity x minus 4. Right? X minus 4 was the only factor of the LCD that didn't cancel there. Then I have minus, and then in the second product, 7 over x minus 4 times the LCD, I have x minus 4 in the denominator and x minus 4 in the LCD. Those cancel. So now I have minus 7 times the quantity x minus 1. And we will distribute the 2 and distribute the negative 7. Don't forget to put the negative with it. Right? Remember, this is like plus negative 7 times x minus 1. And we'll simplify. Then in the denominator, see the x minus 1's canceling again. And that'll be 6. What's left over is 6 times the quantity x minus 4. Now I'm going to leave the denominator factored for now, and we'll simplify the numerator. But look at this. All right, I started off with this complex fraction, fractions within fractions. After multiplying the numerator and denominator by the LCD, you have a fraction that's not complex anymore. Right? This is not complex. There are not fractions within the fraction anymore. Right? There's a single numerator and a single denominator. Alright, now you'd have 2x minus 7x, that'd be negative 5x when combining like terms. Then 2 times negative 4 is negative 8. Negative 7 times negative 1 is, positive 7. Negative 8 plus 7 would be minus 1. Okay, and that doesn't factor any further, so I can put the 6 in down here. That'd be 6x minus 24. And yeah, that doesn't factor any further. I guess you could pull out a negative 1 if you wanted, but and this you could pull it a 6, but there are no common factors. Right, there are no common factors in the numerator and denominator here. Okay, so that original expression, right, this original complex fraction is equivalent to this fraction, this simple fraction here with a single numerator and a single denominator for any value of x except 1 and 4. Right, because if x were 1 or if x were 4, you'd have denominators of 0 throughout this problem. But and you can't have denominators of 0 because dividing by 0 is undefined. But for any other value of x, and I leave it to you to check this, go back to the original expression, replace x with 0 or 2 or 5 or something that's allowed, something that won't make any denominator 0, and then do the same in the final expression, and you'll see that they end up giving you the same value all the time. Alright, so this is what I'm entering. Now notice back in the assignment page, they're only, they already have the division bar there, they already have the fraction bar, so you're just entering the numerator and denominator separately. Alright, the numerator was negative 5x minus 1. The denominator was 6x minus 24. Right. And they already have the fraction bar. Submit, and great. Now, after every question, whether you get it right or wrong, there is an answer explanation. Please read this. If you're right, read through it to make sure you got it right for the right reasons. Or maybe they go through an alternate method that you didn't think about, and it'll add to your tool set and you can use it in the future. And if you're wrong, definitely read the answer explanations. Because, maybe hopefully you'll see where you went wrong, why you were wrong, and you can learn from your mistakes and do better in the future, hopefully. Okay, next question. Now we're doing the same thing every single question, right? We're asked to simplify a complex fraction, right? Write a complex fraction, with fractions within fractions. Write it as a single fraction with one numerator, one denominator that is simplified, right, with no common factors in the numerator and denominator. All right, so this time they're asking us to do the other method. And as I said at the top of the video, you can use the LCD method that I just did for the first question, or this method here where you write it as a division problem. And either way will work. Right, you choose which one you like better. So we have simplified complex rational expressions by writing the expression as division. All right, so I'll write this problem out and show you what they mean by that. All right, so we're given this complex fraction. They're saying write it as a division problem. Remember, this long bar here is again the main division in the fraction. So I could rewrite I could rewrite any fraction, but especially this one. I could rewrite any fraction as a division problem, where this whole expression up here, right, the 3 minus 3 over a plus 2, that's the numerator. I'll write that first. So in parentheses, 3 minus 3 over a plus 2. And then we have division. I'm going to change this to the division symbol. Alright, this division symbol represents the main fraction bar. And then everything below the main fraction bar is what I'm dividing by. So the quantity, in parentheses, 1 over a plus 2 plus a over 3. Alright, and now what I'm going to do, after I rewrite as division, is now I want to take each of these expressions here and write them as a single fraction. Right? Get these as a single fraction. And then we'll basically be working on a problem where we're just dividing fractions, and you've seen that in previous exercises, previous videos, previous assignments. Alright, so I'll start with the numerator. Alright, the numerator being everything above the main division bar. 3 minus 3 over a plus 2. Well, 3 is like 3 over 1, right? And I want to get these to be a single fraction. Now remember, when you're subtracting, you need a common denominator to be able to put them together and make a single fraction. They don't have the same denominator. Right, I'm hoping you're seeing that the LCD for these two fractions is a plus 2. So I would just be multiplying 3 by a plus 2 and 1 by a plus 2. Right, I'd take this fraction here and multiply the numerator and denominator by the quantity, don't forget the parentheses, a plus 2, and then we'll be distributing 3 here. So this would be what, 3a plus 6 over a plus 2. Right, that's the same as 3 over 1. Minus, and then 3 over a plus 2. And now I have the fractions with the same denominator, a plus 2, and that will be the denominator of the difference. Right, remember, that common denominator stays when you're adding or subtracting like that. And then you just combine the numerators. Right? 3a plus 6 minus 3, that'd be 3a plus 3. Right? Plus 6 minus 3. Alright, so this is the numerator right here. Right? Now I'm just putting it in a circle, but that's not the answer, but that's this first fraction. That's this first expression here before the division symbol. And I do the same thing with the denominator. Everything below the division bar or after the division symbol. So that's 1 over a plus 2 plus, and then a over 3. And now again, I can't add these the way they look right now because they have different denominators. But that's easy to fix. Right? This first fraction, I multiply the numerator and denominator by 3. And that'll give me 3 times a plus 2 in the denominator, 3a plus 6. And the other fraction, I'd multiply the numerator and denominator by a plus 2. Right. Now they have the same denominator, right? The first fraction would just be 3 over 3 times a plus 2. Now if you want to write 3a plus 6, that's fine, but you know me, I like to keep denominators factored while adding and subtracting. Plus, and then a times a plus 2, that's a squared plus 2a. Right. over, and then again the same denominator, 3 times a plus 2. And now that these have the same denominator, I can put them together. And the denominator stays, right? 3 times the quantity a plus 2. And when I add these numerator terms, well, no, there are no like terms, so I just say, positive a squared, positive 2a, and then a positive 3. Right? All right, so there, again, I'm putting this in a circle. This isn't the answer. And we're dividing these. All right, we're dividing these. Big fraction bar between them. So I'm going to rewrite this now. The first expression here before the division symbol becomes this, right? So now we have the following, right? Now we have this division problem. We have 3a plus 3 over a plus 2. Right? That was the numerator, the expression before the division symbol, divided by, right, that was the main fraction bar, divided by, right, as a division symbol. And then after the division symbol, what we're dividing by is this fraction, right? When we put it together as a single fraction, we have a squared plus 2a plus 3 and then divided by 3 times a plus 2, the quantity a plus 2. And now this is any division problem you've seen before, right? You've seen division of fractions back in section, I think it was 7.1, dividing fractions, dividing rational expressions. So our first thing is I'm going to factor everything. So the numerator of this first fraction factors to 3 times a plus 1. The denominator is just the factor a plus 2. You can put it in parentheses if you want, but really you don't need to. Divided by, now a squared plus 2a plus 3. This does not factor. There are no factors of 3, positive 3, that would add up to positive 2. Or you could do the b squared minus 4ac method, 4, that'd be 4 minus 12. That's negative, that's not a perfect, negative numbers aren't perfect squares at all, so like that's not factorable. So a squared plus 2a plus 3, right, I'll put parentheses around it letting me know that, hey, that's the only factor. That's as factored as that gets. Divided by, and then 3 times the quantity a plus 2. Right, and then, so I've factored all the numerators and denominators of these fractions. And then you have to recall that when you're dividing by a fraction, or when you're dividing by anything, you can rewrite it as a multiplication problem, right? You rewrite it as multiplying by the reciprocal of that fraction. So now we have this. 3 times, the first fraction doesn't change, right? 3 times a plus 1 over a plus 2. But now the division problems becomes a multiplication problem. Times, and then the reciprocal of this, right? Flip it over. Numerator becomes denominator, denominator becomes numerator. So 3 times a plus 2 in the numerator, and then the a squared plus 2a plus 3 in the denominator. And we multiply, right? Now multiplication, when you multiply fractions, they don't need the same denominator. You just multiply the numerators, multiply the denominators, and you're finished. Well, then simplify, of course. So in the numerator, I have a factor of 3, another factor of 3 that'll make 9, right? 3 times 3 is 9. Times, you have a plus 1. Times, you have a factor of a plus 2. In the denominator, I have a factor of a plus 2, and then this other factor of a squared plus 2a plus 3. And I'm seeing the common factors here. There's a common factor of a plus 2, and that's it. All right. Those are the only things that cancel. and here's what I'm left with. In the numerator, I have 9 times the quantity a plus 1. In the denominator, I'm left with, and now since it's the only factor left, I don't need parentheses around it. It's a squared plus 2a plus 3. And there you go. This is as simple as that fraction gets. Now, if you'd like to multiply the numerator out, you can. That'd be 9a plus 9 over a squared plus 2a plus 3. Alright, same thing, equally valid. So that expression we were given in the very beginning, right, this complex fraction here is equal to this fraction I got at the end for any value of a except, -2. And let's see, are there any other scenarios where something is in a denominator? See, -2 would make all these denominators 0. Same thing with the denominators here. A squared plus 2a plus 3 is in the denominator, but that'll never be 0 for real numbers. So yeah, this is the only value that's not allowed. So you can replace a with any other number you want, and the value of the original expression should be the same as the value of this final one. Alright, so and you can enter things in factored form or when it's multiplied out. I'm gonna enter it multiplied out. It doesn't really matter. It'll accept either one as long as they're equivalent and simplified. Okay, so yeah, once again they already have the division bar there, so you just need to enter the numerator, which was 9a plus 9, or 9 times the quantity a plus 1 if you want, and the denominator was a squared plus 2a plus 3. And that should be good. Wonderful. And once again, please, read through the answer explanations. See, they're changing the division to multiplication by the reciprocal. All right. So now we've seen both methods, right? This LCD method and also the writing as a division problem method. So here we're going back to the objective on using the LCD. So once again, I'll write this out, and we'll do that. Alright, so again, this time I'll do a little less work, or a little less writing. Hoping you see that all these denominators here, the lesser denominators, x plus 3, x minus 3, x plus 3, the LCD would be x plus 3 times x minus 3. Alright, so I'm going to multiply the entire numerator by the LCD. We're going to have to distribute, right? You're multiplying each term, each of these fractions. There are 2 terms up there by the LCD. And there's only one fraction in the denominator, getting multiplied by the LCD as well. And the whole reason for doing this, right, we saw it in the first question in this video, is to cancel all those lesser denominators, right? It'll change this complex fraction, into a fraction that's not complex. All right, so I'm just going to talk it out. All right, up in the numerator here, above the main bar, the first fraction, 4 over x plus 3. When you multiply it by the LCD, see the x plus 3's would cancel, and I'd be left with 4 and the quantity x minus 3. So 4 times the quantity x minus 3. Alright, then I got minus. Then this second fraction, 7 over x minus 3. When I multiply that by the LCD, the x minus 3's cancel, and I'm left with the 7 and the quantity x plus 3. 7 times the quantity x plus 3. Alright, there's the numerator. See how there's no more fractions within the numerator. Right? And then the denominator, everything below the main bar. Right, when I take this fraction, 6 over x plus 3, and multiply it by the LCD, you see the x plus 3's would cancel, covering those up. And I'd be left with 6 times the quantity x minus 3. All right, and I'm going to leave the denominator factored, and we'll simplify the numerator. All right, so distributing the 4 here to the x minus 3, and distributing the negative 7, right, not just 7, we'd have the following. 4x minus 7x would be negative 3x. Negative 12 minus 21 would be a negative 33. All right, negative 12 minus 21. And then there's the numerator, and the denominator has 6 times the quantity x minus 3. Now the numerator can factor. That's you can pull negative 3 out of that, and then you'd have x plus 11. And look, yes, there is a common factor, right? Because 6 is 2 times 3. Right? When I break 6 up, and you see the common factor of 3. So this can simplify. And remember, factors of negative 1 you can pull out front. So I'm putting negative 1 out in front of the fraction, and then we have just x plus 11 left over in the numerator. And 2 times x minus 3, which would be 2x minus 6, left over in the denominator, and there you go. So we the opposite, or negative 1 times, and whatever the value of this fraction is. All right, so the original expression has the same value as this last expression for any value of x except 3 or negative 3, right? Because 3 and negative 3 would make denominators 0 throughout this problem, and that's bad. Right? So this is what I'll enter here. Well, I guess I should put the negative sign into one of the numerator or denominator, because that's what they're having us do. All right, so going back here, let me just put the negative into the numerator. Make that negative x minus 11 in the numerator, and then 2x minus 6 in the denominator. All right, so this is what I'll enter, because they're having me enter the numerator and denominator separately. All right, so I can't put a minus sign out front like I want. All right, so the numerator, negative x minus 11, denominator 2x minus 6. And that's as simple as that would get. Great. All right, and once again, please, read through the answer explanations. All right, next question. This one is again, they're switching. It looks like they're alternating here. You can use the LCD method if you want. You'll end up with the same result as if you do this division method. So once again, I'll write this problem out, and we'll simplify it by rewriting it as a division problem. Okay, so as I did with a couple questions ago, I'm going to start off by just rewriting this as a division problem. Everything above the main bar, that's the numerator. I'll put that in parentheses here. We have 2 minus 2 over u plus 2. All right, that's everything above the main bar, divided by, and then everything below the main bar, right, the denominator. In parentheses, 1 over u plus 2 plus u over 2. All right, and now I'm going to rewrite each of these as a single fraction. All right, so I'll put n for numerator. So we have 2 over 1 minus 2 over u plus 2. So all that would need to be done here is I'd multiply the first fraction by u plus 2 over u plus 2. Okay. So this would give me 2u plus 4 over u plus 2. Right, that's the same thing as 2 over 1 minus, and then 2 over u plus 2 and putting these together, right, they have a common denominator now. That'll be the denominator of the difference, right, u plus 2. And then 2u plus 4 minus 2 would be 2u plus 2, or 2 times u plus 1, right? Because I'm eventually going to be factoring these things, so 2 times the quantity u plus 1 divided by, and then u plus 2, right? And u plus 2 is as factored as it gets. So that's going here. Right? That expression will replace this expression before the division bar, or the division symbol. Then the denominator, and I'll put d for denominator. We have 1 over u plus 2 plus u over 2. Again, I want a common denominator. I would multiply the numerator and denominator of this fraction by 2, and the numerator and denominator of this fraction by the quantity u plus 2. Now they have the same denominator, this 2 times u plus 2. All right, so we have 2 over 2 times u plus 2 plus, and then u times u plus 2 is u squared plus 2u, u squared plus 2u, over 2 times u plus 2. And now they have the same denominator. Right, I'm adding them. That'll be the denominator of the sum, 2 times the quantity u plus 2. And the numerator, adding those terms, you just have u squared plus 2u plus 2. And this is not factorable. Right, there are no factors of 2 that add up to 2. You could do the whole b squared minus 4ac method as well. That'd be 4 minus 8, which would be negative, not a perfect square. So that's not factorable. So that's as factored as that gets. And this expression will replace this. So now I have the following. We have 2 times u plus 1 divided by u plus 2. All right, the numerator divided by, and then this expression after the division symbol became this, u squared plus 2u plus 2 over, and then 2 times u plus 2. Right, and then I rewrite this as a multiplication problem. Right? Remember division, whenever you're dividing by something, you should think of it as multiplying by the reciprocal. So the first fraction doesn't change, but then we're changing divided by this fraction to times its reciprocal. So 2 times u plus 2 in the numerator, and then u squared plus 2u plus 2 in the denominator. And the only common then multiply, right? Actually multiply. The numerator, you have a factor of 2, another factor of 2, that'll make 4. 2 times 2 times u plus 1 times u plus 2. And then the denominator just has these two factors, right? U plus 2 times u squared plus 2u plus 2. And the only common factor I am seeing in the numerator and denominator is the u plus 2. So I cancel those, and I'm left with 4 times the quantity u plus 1 in the numerator. And the only factor left in the denominator is this u squared plus 2u plus 2. And this is great. You could leave it this way, or actually just multiply out the numerator. That'd be 4u plus 4. And then you have u squared plus 2u plus 2 in the denominator still. And this is equally valid, and this is actually what I'm going to enter. They want me to enter the numerator and denominator separately. Alright, so the value of the original expression we were given will always be the same as the value of this expression, right, for any choice of u except negative 2. Right. If u were negative 2, you'd have denominators of 0 throughout this problem. And u squared plus 2u plus 2 will never be negative, or never be 0 for any real number. Right. So negative 2 is the only one that's not allowed. And I leave it to you to test other values of u if you wish. Replace u with any number you want except for -2, and the value of the original expression should be the same as the value of this final fraction we have here. Alright, let's enter this. Alright, so numerator, 4u plus 4, denominator u squared plus 2u plus 2. And that should be good. Alright, wonderful. Alright, so again, please see you can write things factored as well. Alright, as long as they're equivalent, it'll take it. Alright, next question. Let's see if it keeps alternating. Yeah, it looks like it's doing that. Alright, so back to the LCD method. Alright, back to the LCD method. Alright, so I'm hoping it's obvious here what the LCD is, right? All these lesser denominators, x minus 2, x minus 6, and x minus 6 again. So the LCD would just be the product of x minus 2 and x minus 6. Alright, so I'm going to multiply both, the numerator and denominator, right, everything above the main bar by the LCD, by this x minus 2 times x minus 6, and this will be distributed. Right? There are two fractions being added up here, and then there's only one fraction in the denominator. Multiply this by the LCD as well, right? What you do to the numerator, you must also do to the denominator. Right? Okay. Now, the whole reason for doing this, right? The multiplication by the LCD is to cancel, divide out all those lesser denominators, and we'll change our complex fraction into a fraction that's not complex. So up in the numerator, right, this first fraction, -1 over x minus 2 times the LCD, the x minus 2's would cancel, and I'd be left with -1, don't forget the minus, right? -1 times the quantity x minus 6. Then we have plus, and then the second fraction multiplied by the LCD, the x minus 6's would cancel, and I'd have 4 times the quantity x minus 2. Now in the denominator, the x minus 6's would cancel, and I'd have, again, don't forget the minus here, -8 times the quantity x minus 2. Alright, and I'll leave that the way it is right now. We'll simplify the numerator first. So distributing the -1 to the x minus 6 and the +4 to the x minus 2, and then combining like terms, we'd have -x plus 4x is 3x, and +6 plus -8 be -2. 6 plus -8, 6 minus 8. So the numerator is 3x minus 2, and that doesn't factor any further. And the denominator, since this doesn't factor any further, and I'm not seeing 3x minus 2 as a factor in the denominator, this will be as simplified as it gets. So you can put the -8 in, make it -8x plus 16. And this is totally valid right here, right? And the only values x can't be are 2 and 6, right? Because those will make the denominator 0, but anything else is fine. Now, very often, I know some people don't like having a negative coefficient as their lead in the denominator. So if you multiply the top and bottom by, multiply the numerator and denominator by -1, you'd have -3x plus 2 in the numerator, right? And then 8x minus 16 in the denominator. Right. This is also equally valid. If I just again times -1 times -1, right, multiply the numerator and denominator by -1, and again it's really just a preference of mine as well. I don't like having negative coefficients lead my denominators, so I'm going to type in this second expression. So the numerator I had was negative 3x plus 2, and the denominator I had was 8x minus 16. And that should be, as as simplified as that gets, that should be good. Okay. See, they did the same thing where they took the expression there and multiplied the numerator and denominator by -1. Again, for some reason, it's just been historically preferred not to have a negative coefficient leading in your denominator. All right, next question. All right, the LCD method one more time here. So this time, though, both the numerator and denominator have the sum of two fractions. Right, so we'll be distributing the LCD in both the numerator and denominator. Right, so once again, I'm asked to simplify this using the LCD. This is yet again another pretty simple one. The only denominators within this fraction are x plus 1 and x minus 3. Right? So the LCD is just the product of x plus 1 and x minus 3. Right? And I'm going to be multiplying everything in the numerator by the LCD. Don't forget we're distributing this, right? Both of these fractions up here will be multiplied by the LCD. And now we have an example where the denominator also has two terms. It's the sum of two fractions. So each of those will also be multiplied by this LCD, this x plus 1 times x minus 3. So I'll be distributing that as well. And the whole reason for doing this, right, multiplying the numerator and denominator by the LCD, is to clear away fractions. These denominators should all cancel. All right, so in the numerator, the first fraction, you see when I multiply it by the LCD, the x plus 1s would cancel, cover those up, and I'd have -4 times the quantity x minus 3 left over. Right, so -4 times the quantity x minus 3. All right, then plus the second fraction times the LCD. The x minus 3s would cancel, and I'd be left with 3 and the quantity x plus 1. Okay, and we'll simplify that in a second. Same thing down here. In the denominator, the first fraction multiplied by the LCD. The x plus 1s would cancel, and I'd have 4 times the quantity x minus 3. And plus, and then the second fraction times the LCD, the x minus 3s would cancel, and I'd have 2 times the quantity x plus 1. Now be careful with this. People might think, oh, let's cancel the x minus 3s and let's cancel the x plus 1s. You can't do that here. These are sums, not products. These are not factored. These are sums. You can't cancel parts of sums. You can only cancel parts of products, factors of products. So for this, I must simplify both the numerator and the denominator. So I'm distributing the -4 here, the +3 here, and then in the denominator, distributing the 4 here, distributing the 2 here. And we'll combine like terms. So in the numerator, I'd have -4x plus 3x, that'd be -1x. Then +12 plus 3, so plus 15. So the numerator is -1x plus 15. Denominator, we have 4x plus 2x would be 6x. Then -12 plus 2 be -10. All right, -12 plus 2. Now you can factor out a 2 from here, but that would just be 2 times 3x minus 5, and there's no factor of 3x minus 5 in the numerator, So this is as simple as it gets right here. So the value of our original expression before all the writing is equal to the value of this expression for any value of x, except the following values of x, right? You can't plug in values of x that make denominators 0. So -1 and +3 are not allowed. They make denominators 0 throughout this problem. And at the very end, you see 6x minus 10. So x can't be 10/6 or 5/3 either. Because if you replaced x with 5/3, the denominator of the very final expression would also be 0. So for any other value of x, right, the value of the original expression will be the same as the value of this one. And I leave it to you to test that out. Check out different values of x. Alright, so numerator. The numerator I had was -x plus 15. The denominator I ended up with was 6x minus 10, and that's a totally simplified fraction, right? No common factors in the numerator and denominator. Great. Alright, so that's it for that LCD objective. So now we just got 2 more questions where we're rewriting the problem as a division problem. Right. And as I've said before, though, if you like the LCD method for these simplifying complex fractions, you can always use it. It will always work. Same thing here. If you like the division problem, if you like rewriting it as division better, you can always do that too. Alright, so this one's real nice because it's already a single fraction divided by a single fraction. I don't need to do any adding or subtracting like in previous questions. So this one should be real easy to do with the division, writing as a division problem. Alright, so as I've been doing with these, for this objective, taking everything above the main bar, right, writing that down, 6m divided by m plus 5. And then the main bar will be replaced or represented by the division symbol. And then everything below the main bar after that. Right, the fraction 24m squared over m squared minus 25. So we're taking that numerator fraction divided by the denominator fraction. Alright, great. Now I just treat this like any other fraction division problem we've done. Factor everything. Now 6 you could break 6 up into 2 times 3, but I'll leave it as 6m for now. And m plus 5 is as factored as that gets, right? And because it has multiple terms, you can put parentheses around it if you want. You don't need to, but I like doing it on occasion. And then remember, dividing by a fraction, we're gonna, dividing by anything. When you see division by something, you can rewrite it as multiplication by the reciprocal. Oh, you know what? I wanted to factor things first. I'm sorry. So still division. Sorry. Still division. And then 24m squared. Again, you can break up 24 to 3 times 8, which is 2 cubed. 2 cubed times 3. I'll leave it as 24. All right. Then we have times m squared. And then m squared minus 25. All right, that's a difference of squares. That would factor to m minus 5 times m plus 5. Alright, now I'll rewrite as a multiplication problem. So we have 6m over m plus 5 times, and then the reciprocal, right, m minus 5 times m plus 5 are in the numerator now. And then 24m squared in the denominator. Now, I've been multiplying first, then simplifying. You can simplify, then multiply if you wish. So if you look at the the factors of the numerator are 6, m minus 5, and m plus 5. Factors in the denominator are m plus 5, 24, and 2 m's, m times m squared. So there's an m plus 5 in the numerator and m plus 5 in the denominator. Those will divide to be 1. There's an m in the numerator. There are 2 factors of m in the denominator, so only one of those is going away. So I'm still left with m. I'm just changing that power to m to the first. And then 6 and 24 have a common factor of 6. All right, this is 6 times 1, and 24 is 6 times 4. So I still have a factor of 4. That's why I wrote 4 there down in the denominator. Okay, so in the numerator, the only factor I'm left with is m minus 5. And since it's the only factor, I'm going to not have parentheses around it. No need. And then the denominator, the only factors left are 4 and m. And there you go. This is as simple as that final fraction gets. And once again, you can check this out, test some values of m. All right, replace m with anything you want except for certain values, which I'll get to, and the value of the original expression should be the same as the value of this final one. The only values of m you can't use are ones that make denominators 0, so negative 5 and positive 5. Obviously, right, they make those denominators 0 here, but also 0 itself, right? Because it would make that final denominator 0. So, you know, again, if there's ever a denominator of 0 throughout the entire problem, then that value of m is of the variable is no good. But you can plug in any other value of m you wish, and the value of this last fraction should be the same as the value of our original expression, and you can test that out if you want. Okay, so what I'm entering here, the numerator ended up being just m minus 5, and the denominator just 4m. And that's it. Wonderful. All right, so I should have just one more of these. Rewrite, that where they're asking us to rewrite the complex fraction as a division problem. And this is, oh man, this is very, very similar to the last one I just did. All right, so once again, I'll write this out and we'll rewrite it as a division problem, factor everything, then write it as a multiplication by the reciprocal and cancel common factors and be done. All right, so just like the last question. This fraction here above the main bar is the numerator, right? I'm writing that first, 3q over q minus 5, and then we're dividing by, and you know what, I'm gonna factor everything now. All right, so 3q is as factor as it gets, q minus 5 is as factor as that gets. Dividing by, right, that represents the main bar, and then this fraction below the main bar is what we're dividing by. 24q squared, I'll leave as 24q squared over, and then q squared minus 25 factors to q minus 5 times q plus 5. Right, so I factored everything right now. And you could factor 24 to 3 times 2 cubed again if you want, but I'll leave it as 24. And we'll deal with it later. Alright, so now everything's factored, cool. Rewrite division as multiplication. Dividing by something is multiplying by its reciprocal. So again, the first fraction doesn't change, right? 3q over q minus 5. It's the second one that we flip, right? Division becomes multiplication, and we're multiplying by the reciprocal of that second fraction, right? Q minus 5 times q plus 5 is in the numerator now. The 24q squared in the denominator, and you see how very, very similar this is to the last problem. And you could multiply them, cool, but we know the factors. The numerator has factors of 3, q minus 5, q plus 5. The denominator has factors of q minus 5, 24, and q, right, q squared. So I'm seeing a q minus 5 factor in the numerator, a q minus 5 factor in the denominator. Great. There's a factor of q in the numerator. There are 2 factors of q in the denominator. Only one of those will cancel, so I'm left with q. And then 3 goes into 24 8 times, right? This is 3 times 1, so that becomes 1. And 3 would cancel here, you'd be left with 8. All right. So in the numerator, the only factor left is q plus 5. And in the denominator, the only factors left are 8 and q. And that's as simple as this gets, right? And the value of our original expression will be the same as the value of this expression for any value of q except for 5, -5, and 0, right? Because those will make denominator 0 throughout the problem. But any other value of q would be valid and allowed to be plugged in. All right, so again, very simple there. No addition or subtraction was needed in that problem either, because the numerator and denominator were already a single fraction. Right? I didn't need to do anything to make them into single fractions like in earlier questions. So numerator q plus 5, denominator 8q. And that should be it. And again, please read through answer explanations when you're done with questions, whether you're right or wrong, just to check yourself. And that should be it for this version of this assignment. As I said at the top of the video, please understand that this version of the assignment I did here is not going to be exactly the same version that you're doing. The questions will probably be different, but the objectives will be the same two objectives. The types of questions you're expected to do will be similar. And the way you would do them, right, that LCD method or the writing as division method, those methods won't change, right? They'll be the same procedure as well. So I'm hoping that watching me do this here, practicing along with me, will help you when you work on this assignment on your own. And thank you very much for watching.